Welcome to part 7 of the Recursion video series. In today's video, we'll be talking about Leetcode problem 78 subsets. So that is a backtracking based problem. I covered what is backtracking in my previous video, part 6. You can find it in the playlist below. You can also find the whole Java solution to today's problem in the description below. So without further ado, let's get started. Leetcode problem 78 subsets. So in this problem, what they ask you to do is they'll give you an array of distinct integers. Okay, so that's important, it's distinct, because this solution won't work as it is if the numbers are repeating. So they give you an array of distinct integers and they want you to come up with all possible subsets. So what do we mean by that? Suppose they give you 1, 2, 3, okay? So suppose I give you these three numbers, 1, 2, and 3. Now I ask you, like this, 1, 2, and 3. I give these to you and I ask you to pick whatever you want. You might choose not to pick anything, okay? In which case, your result set, this is the result set on the left, this is empty. You might choose to pick all three of them, okay? In which case, your result set is all three of them. The green one is the result set. Or you might pick 1 and 2, okay? Which is this guy. So the thing to notice here is if you pick these two numbers, you pick 1, 2 or 2, 1. That does not make a difference. All it means is you have both 1 and 2. So you can pick 1, 2, you can pick 1, 3. So you can pick anything out of this that you want. So they want you to come up with a list which has all those possible subsets. So first let's think, how would we solve this on pen and paper? Okay, so if you were solving on pen and paper, one way to think about this is so forget these people for now. These people will come later on when I explain the code. For now, ignore the people standing here. Suppose you have 1, 2, 3 numbers, okay? So one way you can do is you have 1 in the final set, and another way you can think of is where you don't have 1 in the final set, okay? Then once you come here, you can decide to include 2 in your final set, or you can not have 2 in your final set. So green is the final set, this is what is remaining. So now once you're here, you can decide to have 3 in your final set, or you can decide not to have 3 in your final set. So at this point, so the one in blue is the remaining numbers to choose from. So at this point, you don't have anything left to choose from. So one subset is 1, 2, one subset is 1, 2, 3. And similarly, you can do all of this also. Like you decide to explore a path without 1. Okay, now once you're here, you can explore a path with 2, explore a path without 2. Once you're here, you can explore a path with 3 because 3 is only one remaining. You can explore a path without 3. And when you have nothing else to choose from, that's where you reach one subset. So now, this is how you would solve with pen and paper. Now, how would you do the same thing in code? So the way to do it in code, one way is you will have a helper method where you will have two lists, a chosen list and a remaining list, okay? So when you call that method, so first I'm going to tell you how to solve without backtracking with just recursion, and then we'll improve it by adding backtracking. So first is you have two lists, a chosen list and a remaining list. So you call that method with two new lists. So this empty glass, every glass is a list, okay? So this glass is a chosen list, this is the remaining list. So the remaining list you have 1, 2, 3, 3 numbers in there, 1, 2 and 3. So you call here with 1, 2, 3 in the remaining and chosen is empty. Now from there, you can create another two lists, okay, for this guy. So 2 new lists. Again, this is without backtracking. So you're creating 2 new lists. You're not passing the same list. You're creating 2 new lists. This guy gets 1 in the chosen list and 2, 3 in the remaining list. And you call another recursive call to itself where you have empty in the chosen list and 2, 3 in the remaining list. There's 2, 3 here. So for the rest of the videos, you just have to trust me. The numbers which I say are in there. So there's 2, 3. So this guy gets a list with chosen empty and remaining 2, 3. And like I said in my previous videos, every recursive call to the method or to itself or to another method, every recursive call is a new stack frame. So when it calls itself, this is another stack frame. Now this makes two calls, both get separate stack frames. So every call to the method creates a new stack frame. So you can think of these stack frames as people, and all these people, which is all these stack frame, will do one small part of the job and give the rest to the next guy. So what this guy does is he gets two cups or two lists, one chosen, one remaining with 1, 2, 3. So he's just going to do one part of the job where he will explore a path with one and without one. So this guy will create two new lists, 1, 1, 2, 3, give it to this guy. Create two new lists, empty glass, 2, 3, give it to this guy, okay? This guy is done. He's not going to do any more work. Now this guy, he gets a cup with 1 and 2, 3. What he does, he'll create two new lists. With 1, 2 and 3, give it to this guy. With 1 and 3, two new lists, give it to this guy. Now this guy again will do the same thing. He will create two new lists. One with 1, 2, 3 and empty, give it to this guy. This guy will create and two new lists for this guy, 1, 2 and empty, give it to this guy. So when these guys get the cups, they realize that they have nothing else to choose from. This is empty, right? So the remaining is empty. This is the remaining, it's empty. Same for this guy. His remaining is empty. So that is where we've reached the base case. So this guy will say 1, 2, 3 is one of the results. This guy will say 1, 2 is one of the results. So now this will work, okay? But this is without backtracking. So here the problem is, if you notice, there is a lot of new lists being created. This guy creates two new for here, two new for here. This guy will create two new for here, two new for here. There's too many new lists being created. That's a very inefficient solution. So a more efficient solution is you use the same two lists all throughout. So if you watch my previous videos, I talk about reference type and primitive types. So reference type is shared across all the stacks. So a more efficient way is what we do is we use the same two lists. We are not going to create. So here, the previous example I gave you, this guy had his own two lists. This guy had his own two lists. This guy had his own two lists. So we are not going to do that. In backtracking, what we do instead, we use the same two lists. So this guy has 1, 2, 3. What he'll do, he'll take 1, put it here, give it to this guy. Okay, two lists. What this guy is going to do is take 2, put it here, give it to this guy. This guy does whatever he has to do, all the recursion comes back here. Now he takes the 2 out, 1 here, 3 here, gives it to this guy. This guy also finishes everything. When it comes after this, so one part I forgot to tell you. In backtracking, whatever you hand over to this guy or any guy, he has to hand it back after the thing is done in the exact same state. So when this guy got it, he had 1 here and 3 here. So he will do whatever he wants here. But when he hands these cups back to this guy, it has to be the same state he got it, which is 1 here, 3 here. So what this guy is going to do when he gets these 2 cups, he is going to put 3 here, okay? Give it to this guy. This guy is going to put 1, 3 in the result and then give it back to this guy, the exact state he got it. Now he's going to put just 1 here and give it to this guy. This guy will put 1 in the result, hand it back. Now see, at this point, when this guy hands it back, there is 1 here and this is empty. But that is not how he got it. When this guy handed it to him, there was 1 here and 3 here. So he has to put 3 back here. Now this is the key part in backtracking. This is the backtracking part, because when you hand these back to this guy, it has to be the same state he got it in. So he got it 1, 3, he will hand it back 1, 3. Now, when this guy hands it back to this guy, he has to hand it back in the exact same state he got it. So when he gave it to him, there was 2 and 3 here, right? 2 and 3 here, 1 here. He will give it back the exact same way to this guy. So that is the backtracking part of it. You have to give it back in the same state that you got it so that the previous stack can continue from wherever they left off. So that covers the backtracking part. Now let's see. And again, if you find that part a little confusing, what my previous videos, I go a lot more into detail, especially the first 3 videos about reference and primitive types. So let's see. So now another thing to remember here is when you write the code, it's not gonna execute this and execute this. This is how you think of it when you create a decision tree. But the way it will actually execute is from here, the control will come here. So this stack frame, after that this stack frame will be created, then this stack frame will be created, then this stack frame will be created, this guy will write to the result, this will be popped off the stack, you come here, this stack frame is created, this guy will write the result to the final list, pop off the stack, from here it comes here, pop off the stack, come here, pop off the stack, come back here, from here it will come here, back up here, and your program terminates. So the order it flows in is very important to understand. Basically, if you think of it in stack frames, that comes very naturally. So let's see, is there anything else I wanted to cover in this? I think, yeah, that's about it. So I'll be covering a few more videos. I'll try to make it a little bit more interesting with more props. Please let me know in the comments if there is something you liked or disliked about the video. All right, thank you.